Recording is on. I guess I will stay here. So this is really the basis of the notes. I'm going to tell you right now, if you don't get what I show you next memorized, you're doomed. You will get the lowest test score of the year. The reason I bring this up is I just have students after doing this for a week, and we are going to have a quiz on Friday next week. That's a week from today, just to get a little checkpoint about what you've learned today, tomorrow, Monday, Tuesday, and Wednesday. And it really is all about a logarithm and what it is, and then input, say it. So you're going to have the ability to input output without a calculator to evaluate a logarithm. And it's all about this video, the definition of what a logarithm is. So here it comes. Don't know if you're going to be able to hear this
Hi,
online.
everybody. Made this PowerPoint years ago, and I figured I'd show you this live. This is what a logarithm is. You have a base to an exponent that equals an answer.
Okay, now hold on. That's not a logarithm. That's just the setup of what an exponential situation is, right? Don't you have a base raised to a power, we'll call exponent, and then I just made up the word equals an answer. That's the answer. This is what a logarithm is. It's just a reshuffling of the positions. I'm going to press play. So we got a movie within a
This is
movie
what a
here.
logarithm is. The word log comes in, and everything
Your
changes
story.
position. 3, 2, 1, go.
That's the logarithm
On
noise.
base B of answer
This is
equals
it.
exponent isolated.
And then I'm going to yell at you right now. There is no, I just don't get logarithms. No, you cannot memorize a change of positions. Ah! Okay? That's all that happens. When you see a logarithm, that little number in subscript is the base now. The answer goes there. The glory and power of a logarithm is to isolate the exponent all by itself on the other side of the equal sign. Now I'm going to play this, and then you get to hear that noise over and over and over again.
Take the word log away.
Things
Everything goes
change.
back to where
Now
we
it
had
goes
it
back to
before.
the original
Base
positions.
number raised to an exponent equals an answer. Let's do that one.
Bring the word log in. Everything switches around. Take it away. Everything switches back. That's it.
That's it.
Okay, that's it. And
How do I get out of this movie?
sadly, last year I had students not memorize that and not be able to evaluate a logarithm after a week. I hope that's not you, but if it is you, then you will be doomed on our next quiz. All right, and it really shouldn't be that bad. It really shouldn't, and we're going to work on it today. All right, but let me give you a better description of what a logarithm is, and I got to hold off on using this word. And let me move my stuff here. I'm wearing my swimming shirt too from 2015, because swimming is at stake too. Dive and swim team, right? So we got dive and swim, we got volleyball, we got football. In the third round of the playoffs, we got some sports going on here at Lockport. Nice. All right. So what's the opposite of addition? Just answer the question. What's the inverse operation of addition? Subtraction. Come on. Subtract. What's the inverse of multiplication? Division. What's the inverse of cubing? So if I have cubes, how do I solve for a cube? Not square root, but cube root. Okay, close, but it's cube root. So we know these opposite or inverse operations. What is exponential inverse? Well, take a guess. I just gave you a movie. What is it called? Logarithm. Hey, when I say inverse, you say what? No, we lost you. When I say inverse, you say. Okay, so here's an exponential. I'm gonna put this anywhere. Stick it wherever you want. I don't care. Right? Up at the top, left, right, whatever. I have a little bit more space here, so I'm kind of cheating. I'm gonna change the letters in our notes below here, and I'm gonna use the letters that I had on my PowerPoint. So you have a base. You have the exponent. You know what though? We're just gonna go x and y. So let's call that y equals b raised to the x instead of e and a. And that's probably what I will change there. Okay, but anyway, when I say inverse, you say switch x and y. So this becomes what? I don't love anything. What's going on here? What? Sorry, did he say that out loud? B raised to the y equals x. Isn't that a switch of x and y, right? Simple as that. Okay, and then the thing I was trying to get in your head on the PowerPoint, here's this word log mysteriously sitting over here. And then when I take this word log and I shove it in front of this exponential scenario, when I drop this, then all of those positions switch. So this is how I solve for y again. So what happens? The base becomes a subscript. The answer position, I guess I could do this. This is the exponent, and this is the answer position. That's what I showed you on the, maybe I could do that and just show you behind the scenes what's happening there. Oh, and then lo and behold, I do get y all by itself. And now that is truly the inverse of this exponential scenario resolved. So a logarithm is proven to be the inverse of an exponential because I switched x and y and then I resolved for y. All right, so that's really what I'm going to change the lower part of this notes here. Let's get rid of this now. I just done taught you. The inverse of this is, let's just say it's just a logarithm, and don't worry about but really what we're going to end up doing, how is this written in terms of a logarithm? Fine, I will write it. It's log base 3 of 7 equals x. This is rewriting this in terms of a logarithm. That's really what it is. That's all. This is why I can't even speak because I'm so upset about my students last year that blew this for like a week and could not figure out just what a logarithm is. That's it. There's nothing else to do. There's nothing complicated about it. You just got to learn the positions. Ugh. Okay? Really got to simplify stuff. I don't know what all this says. I know this is about logs and who cares? Let's change this though. Let's call this b to the x equals y. And then let's change this to log base b, I use a lowercase, of x equals y. Okay, and that's how we're really going to look at this. That's the true inverse of that exponential in terms of our y and x variables, right? Just to make it simple. And I don't even know what we're doing here. I already did the notes up there. It was probably how are these inverses? You really got to lock in on that video. If you want to watch that forever to get those positions, go for it and hear that stupid little noise. But I'm going to use that noise every time I change a log to an exponent and vice versa. Okay, and then really these notes could be pretty quick because this reference, wax on, say it. Wax off, that's the original great, the only one that matters, Karate Kid from the 1980s. Don't even talk about the new version. All right, but anyway, wax on, wax off, that's what these questions are. Can you take 3 squared equals 9 and make it a logarithm? For sure. So this is log. Who's the base, everyone? What number represents the base? 3. Okay, which one represents the answer to the exponential statement? 9. And that equals what? 2. So that's it. That's it. It's just wax on, wax off. Can you change the positions? Okay. I'm going to do the next one because then I'm going to reference the calculator. Log base 10 of, well, in this case, it is of y equals x. Okay, and I have to leave that way, but to truly find the inverse of y equals 10 to the x, I'd have to switch x and y and then write it as a logarithm. And then the x's and the y's would switch. But that's not what they're asking. They're just asking me, take that exponential and change it to a logarithm. All right, and that's all we have to do on that one. All right, just letters, log, doesn't matter. Base r of w equals exponent. Do not forget that the exponent is isolated. The whole point of a logarithm is to get the exponent all by itself. Question. Correct. You must know something about logarithms. With that question, we are going to the calculator, and I'm going to leave the screen for a moment, you people at home that are watching on YouTube, which is usually nobody. Good. I couldn't get my mouse disappeared. I'm going to open the calculator, and then I have this thing in my head, but I have to go up to the screen so you won't hear this part. Hey, go ahead and open up the calculator. And let's play around with this and build some things. Then when the next thing comes up, I'm going to come back to the calculator as well. So I guess I should bring the. Let me just do this. Let me be a professional movie maker. I felt guilty leaving you guys at home here. So, oh, the volleyballers, right? They have to watch this movie. So, hope you guys are winning. Oh, you're not playing yet, but do win. Oh, here we go. Here's the logarithm button. Yes, good. Hopefully I didn't take a video of any of you guys like when I walk by. You could sue me, putting you on the internet. Okay, so it's this button right here. And what is this button? This is the log base 10 button. There is many, many, many things that have invisible stuff, invisible. Here are some invisible things in math. Okay, so x. Hey, what's the power on x? X to the what power? What's this power? 1, invisible. What's the index right here? 2. There's 2 things that are invisible in math. Here's a third, the log base 10 button. Hey, let me ask you a question. This is what you're going to have to do anyway eventually. Oops. What do you think that answer? Stop. Remember, this is a base 10. And then I'm doing log base 10 of 10. 10 to what power equals 10? What's the answer? 1. Enter. Booyah. 10 raised to what power equals 100? 3, 2, 1, go. 2. 10? No. All right. 10 raised to what power equals 100,000? Count the zeros. Count the zeros. Count the zeros. 5. 10 to the 5th equals 100,000. So what I'm showing and proving to you is that log button is log base 10. And this is the kind of stuff that you're going to have to be able to do in your head. You're going to have to be able to evaluate logarithms based off of basically exponent rules. But the only button that you have in your calculator is a log base 10 button and then the log base E button, which I will come back to that when we get that. Let me make sure no students are being shown on the video. Okay. Ooh, I just looked at the ceiling. Let's count ceiling tiles. Nope, actually, some people count floor tiles in this room. Anyway. Oh no. Look at what we got here. By the way, isn't that true? Isn't e to the negative third 1 over e to the third, right? Negative exponent rule. But that's not what they're asking. They're asking to change this into a logarithm. So log, here's the base. Here's the answer. Here is the exponent. That's changing it as a logarithm. And now you need to know that log base E is actually written as ln, the natural log. All right, and that's one extra added component to today. Okay, and then I'm actually going to go and show you why this actually works. All right, so I will go back up. We'll count ceiling tiles. There we go. 1, 2, 3, 4, 5, 6. Sorry. Let's go to the calculator now. All right, and then show you the LN button. I hit that. Come on now. All right, so here's the LN button. All right, so there it is. It's all in red. This is why I get sad when people don't follow along with the graphing calculator, just like in the doing regressions. I still got people that can't do a regression in here. You need to do work on the side. For gosh sakes, just open up a Google search and put regression TI-84, press enter, and you'll see a video from a teacher that will teach you how to do that. We've got to stop missing regression questions. Next thing, what do we have here? We have 1, and we know this is correct, but I just wanted to go through ln'ing 1 over e to the third. And then where's the e button? Look at what's red. I did second ln, and then that's the e caret button. That's taking e to a power. Now, do not do this in your homework. This is what I've been arguing with you all year long. Not arguing, complaining about you. The reason you're enumerate is you use your calculator for everything. And if you start doing this and using the calculator log buttons and LN buttons, you're doomed. There is going to be no calculator on next Friday's thing because you have to demonstrate that you understand what a logarithm is and how to evaluate from that. But I'm just showing you a thing. Boom, -3, right? Isn't e to the -3 1 over e to the third, correct? And then one more point that this is an exponent. When you do these evaluations, these are exponents. That's what an evaluation of a logarithm is, an exponent all by itself. Okay? All right, let's go back. Okay. And then guess what? Reverse. Wax on. Say it. Wax off. So what does this mean? And actually, this would be, you could get this answer. What's the answer for x then? When this changes to 7 squared equals x. What is x equal to then? What's x equal to? What's x equal to? What's x equal to? 49. Okay, and then remember, I'm just putting the positions. B, E, and A. 7 is the base, 2 is the exponent, x is the answer. So this is how I change this back to an exponential. All right, 3 is the base, x is the exponent, y is the answer. So again, get rid of the word log. The 3 positions switch to their regular exponential positions. Okay, what's this base right here? What's that base that's missing? 10. If you don't know that, you're severely and totally, tell them. Severely and totally what? Behind. Hey, what is y equal to? What is y equal to? What's 10 squared? 100. Hey, what's ln? Log base what? What's ln? Log base what? E. And then y? Y? Sorry. Because E is a very important number in growth and decay, real world natural stuff. All right, so that's why E is used a lot. But anyway, I got to know that first, so I know that that's the base, that's the exponent, that's the answer. So this is just a wax on, wax off. Can you change this into that? And therefore, you're solidifying the definition of a logarithm. So that's why I call that wax on, wax off. Just do it, practice it, and then you'll get it solidified to positions, and then you'll be able to evaluate. All right, arrange the numbers so it's a true logarithm. All right, log. What would this be? What would the base have to be so this would be true with the 3 numbers 7, 2, and 4? Would it be 49? Sorry. Would it be 49, 2, or 7? What do you think the base is, everyone? 3, 2, 1, go. 7. Okay, and then what's the exponent, which would be over here? 2. And then what's the answer? 49. It's weird, right? But you got to know what's so special about a logarithm, getting the exponent all by itself. Right, and then this one's great. Ooh, why don't you guys discuss with your friends and see if you can get that one, about 10 seconds. You do have to see what the problem is with logarithms. You got to know your exponent rules. You have got to know your exponent rules. Got to. Good, nice, good discussions here. 5, 4, 3, 2, 1. Hey, what's the base, everyone? 3, 2, 1, go. 6, good. What's the exponent, everyone? -2, and then that gets me that 1 over 36, because 6 to the -6 flips, becomes 1 over 36. Why am I circling the 2? Just to really, in the -2, to make you understand that the exponent is isolated. It's over on the right side of the equal sign. Okay, here we go. Here we go. When I see this question, go ahead and write this down. This is what I used to write in my old-fashioned notes. This really reads or is asking 3 to what power equals 9? So go ahead and write that for note purposes. Equals 9. Because remember, that's what this is. That's an exponent. Okay, everyone knows the answer. What's the answer? What's the answer? Not everyone in third hour. No one's saying anything. 2. 3 squared equals 9. This is what you're going to have to do on Friday next week, and amongst other things. We are going to graph, but guess how we're going to graph? Input, say it. You can't input output if you don't know how to evaluate a logarithm. You're doomed. Okay, What's this one? Ooh, I don't know. Ooh, okay. And then I might go up here and tell you some things that you should know. Who? 2 to what power equals 32? Anyone know? 5. Good. Okay, then you know what? I'm gonna stop this right here. I'm not gonna do our times tables. You better know all your squares, but you better know your cubes and a couple fourths. Obviously, 1 cubed is 1. This is where I'm getting sad. I think some students struggle with this. They don't know their cubes. Like 2 cubed, 3 cubed. You should know up to, I believe, 5 cubed. 4 cubed creates a special number, which is both a perfect square and a perfect cube, which is 64. So 64 is 8 squared, but it's also 4 cubed. I'm in the middle of a video. You want to be in it? Okay. Who's this? Oh, Casa. When are you going? Oh, 4B. Okay. Oh, I just said your name online. You could sue me. All right, that's good. I don't have any money, so. What's the base on this logarithm? I'm a teacher. I just do this for fun. You can see how much I enjoy myself every day. What's the base on this logarithm? 10. So 10 to what power equals 1,000? What's the answer? 3. Powers of 10. Not knowing this. Oh, she distracted me. Gosh darn, squirrel. Okay. Hate the interruptions. You should also know 5 cubed. What's 5 times 5? What's 5 times 5? 25. And if they still had money, I know you pay with your ID for lunch, but what's 5 quarters? How much money is that? How many cents is that? 125. And I think you should know those cubes. And I believe you should know these fourths. 2 to the fourth is 2 times 2 is 4, and then 4 times 4 is 16. 3 to the fourth is a popular one that makes me sad how many students make that hard. Because 3 squared is 9, and then 9 times 9 is 81, which is 4 threes multiplied together. If I have 2 nines, that's 2 threes and 2 threes. You should know what I'm talking about here. 4 to the fourth might be a stretch. I think you should know 5 to the fourth, which is just 125 times another 5. 100 times 5 is 500. 5 quarters is 125. 100 plus 125 is 625. You should know all of these in addition to negative exponent rules and also radical rules. One more thing, maybe I'll write a radical rule up there. Remember, if I have like the cube root of a squared, that equals a to the 2 power 3 index. And I'll highlight that. This is the only thing that crushes students. That and not knowing this. A to the negative first equals 1 over a. So negative exponents and fractional exponents, because logarithms are just exponents. So since logarithms are exponents, you need to know your exponent rules. So I know I got out of there for a second. Oh no. So how do I get log base 16 to equal 4? What do I have to do to 16 to make it 4? What do I have to do? What operation? Square rooting. Okay, so what I would need to do is take the square root of 16, which is 16 to what power? I just went through this. What's the answer to that? Okay, what's 16? What is this index right here? What is that number that's invisible? 2. And then what's this number that's invisible? 1. So I need to raise this to the 1/2 power. So guess what? This is equal to a half. This is where the stuff's going to hit the fan. It's knowing your exponent rules and knowing how this comes about. All right? I have another way that we could do this, and you may or may not like this. Here's an escape. You could actually make this x in your head. You could say, all right, this is what I'm trying to solve for, some unknown. And then you know what you could do? Man, I'm losing my voice. 16 is the base. X is the exponent. 4 is the, and sorry, I just was jumping ahead there. 4 is the answer. And then you could solve this. And I believe we have done this, unless I'm thinking of the other class. But if not, I think we did. We could change this to 4, getting equal bases. And then since I have equal bases, I can drop the 4s and set the exponents equal to each other. And then I get x equals a half. That's an escape on these logarithms and solve it. If you cannot think about the numbers, you will not have a calculator in your hand when you're evaluating these logarithms. I will tell you this though, we are going to quizzes you to death next week. I'm probably going to have a quizzes every single day just to hammer down these logarithm evaluations because of how important it is to be able to do this without a calculator. Hey, 2 to what power equals 1? Any number to this power equals 1. What is the power? 0. This is a big fat 0. And if you don't trust this, then rewrite it as an exponent and check if it's true. Hey, that is true. So I know this is the answer. All right. So change it to an exponent and make sure that you have a correct statement there. All right. And that's another discount double check. What's ln? Log base what? Log base not 10. It's a common mistake. It's log base who? E, and then look at the thing there. So what's the answer then, everyone? What's the answer? Log base e of e to the 7th. Well, what I have to put on this logarithm, I mean, I could do this right now. E raised to the question mark equals this. What does question mark equal? What does question mark equal? 7. So the answer is 7. Okay, that's what the answer is. So anytime, look, I could put a million of these here. Yeah, and I'm going to go above. What's log base 2 of 2 to the 27th? 27. What's log base 7 of 7 to the 43rd? What's the answer, everyone? 43. It's the exponent on that. Are you paying attention? Looked like you were staring at the floor. I know they're exciting. The tiles have so many different colors. All right, and so on and so on and so forth. This is an identity of sorts here. Okay, now we're getting, you want to get nuts? Let's get nuts. What do I have to raise 2 to? What kind of exponent to get it to be a fraction? What kind of number? Negative. So there's the flipping. So number 1, I know I have a negative exponent. And number 2, 2 to what power equals 16? 4. That's it. Wait, I don't get that. 2 base raised to the negative 4th does equal 1 over 2 to the 4th, which does equal 1 over 16, which is that answer. So this is the discount double check to make sure I'm doing the right thing. All right? I'm not going to let the excuses happen. There's reasons why we don't solidify stuff. I think it's how we're doing our homework or whatever. We got to do it legit, invest early, and then we snowball in a positive direction, not negative. Okay, some of you are doing that though. We are getting, remember I told you guys, you are catching up to period 4. All right, so let's keep going. What's the base on this logarithm? 10. Okay, we should all know the answer at this point after the last one. What's the answer? Positive or negative? Negative, and then 10 to what power equals 100? 2. That stopped writing. Okay? Practice, practice, practice. We done with this section? No. Okay. Ooh, I love it. Remember, this is another thing you could do. Change this in your head to log base e, because that's what this is. And then change this to negative 8 for that power. Flip it now. And then honestly, you should know right away that the answer is negative 8. It's the exponent that makes e equal e to the negative 8. I need to tack on a negative 8 to that e. So this is another thing you can do in order to get this, evaluated quick. Oh no! You know what people want to tell me on this one? They want to say it's negative 2. But what's 3 to the negative second, everyone? What's 3 to the negative second? 1/9. So that's a false. So what can I raise 3 to in order to get it to be a negative 9? Is there anything? Could I ever have that happen? No, you cannot. And now you just got down to there are some serious domain issues with logarithms. You cannot take a positive base, raise it to a power, and get a negative output. So that is impossible. There is one more impossibility. What could I raise 3 to in order to get 0 as an output? Now, what's the average student usually say? 0. But my silly little friends, what's 3 to the 0 power? 1. This is another impossibility. You cannot take a number of any base, raise it to a power, and get 0 as an output. It's impossible. It's impossible. All right, so you cannot have a log of a 0 or a negative number. These do not evaluate. What's this last one? What's the answer? Oops. What's the answer? 7 to what power equals 7? Third hour kills me. No one answers. 1. Okay, 1. 7 to the first equals 7. Okay, so it just comes from being focused and, paying attention to the main components of the class. Okay, reading the directions, determine an approximate value, telling which two integers they fall between. Then tell which one you're closer to. Okay, so this is why we need a logarithm to get this exponent. It's going to be a decimal because 18 is not a power of 2. But what is close? 2 to what? 2 to what power equals something very close to 18? 2 to what power? 4. Good. We got somebody. And what is 2 to the 4th? 16. What's 2 to the 5th, by the way? We already had this today. So what's 2 to the 5th? 32. So my powers are between 4 and 5. Which one do you think it's closer to, 4 or 5? 4. So it's closer to 4 because 16 is closer to 18. So it would be 4 point something. You're going to start getting decimal exponents because it doesn't always work out perfectly. All right, and there is a button for that evaluation. I'm just going to hold off on this. What's the base on this logarithm, everyone? What's the base hiding there? 10. Okay, what's 10 to the first? What's 10 to the first? 10. What's 10 to the second? 100. So that means the exponents are between 1 and 2. Who is it closer to, do you think, 1 or 2? It's probably closer to 1 because 10 is closer to 20 than 100. So you get 1 point, I don't know, 1.2, 1.3, something like that. All right, here's what I said about powers of 3. 3 to the third is 27. 3 to the fourth is 81. So the exponent is between 3 and 4. Now, where's 65? Is that closer to, I feel like that's closer to 81, right? So the probably closer to 4. Would probably be like 3.7, 3.8 for an exponent. It's just a guess. It's a ballpark. All right, and then when we get fractions, sometimes this kind of messed with my mind with the honors students because we've already gone through this lesson actually yesterday. I think I went through this yesterday. Yeah. All right, so what's 5 to the negative first? I think I got it. What's 5 to the negative first? What's 5 to the negative first, everyone? 1/5. What's 5 to the negative second then? Now I got it. What's 5 to the negative second? So my answer is between 1 and, or -1 and -2, because 1/20th is in between these two. It really is. All right. What do you think the answer is closer to, -1 or -2? -1 or -2? -2, because 1/20th is closer to 1/25th. All right. So again, it's just thinking though. It also is that hammering down that point of, what a logarithm is. All right, and then here we go. This is weird, but this is easy. Anyone ever hear of the Richter scale? Raise your hand if you've heard the Richter scale. Okay, what is the Richter scale for? What things? Earthquakes. That's why, here's why an earthquake that's a Richter scale of 6 is so different than a Richter scale of 8s. Whenever you're in the 7s to 8s, that is catastrophic. We are talking about buildings collapsing, bridges collapsing, or whatever. It's because for every level, it's a logarithmic scale of base 10. So a Richter scale of 6 compared to 7, Richter scale 7 is 10 times stronger than a Richter scale of 6 because it goes by multiples of 10. From 7 to Richter scale of 8, that's another 10 times stronger. So it exponentially starts going up. So that's why a Richter scale of 5, we have Richter scale 5 earthquakes in Illinois. Do you know we have a little what do you call it? A problem with the Earth down in southern Illinois. So we do get earthquakes in southern Illinois, but they're very tiny. And we would never feel it up here, like at Lockport or even my house in Minooka. Don't be looking up my address. All right, so this is a scale logarithmic in a way, but this is in terms of base 2 logarithmic scale. So here's what we have here. This number right here is 2 to the 0. By the way, what is 2 to the 0? What's 2 to the 0? 1. And then this is 2 to the first, which is what? 2. And then this scale is 2 to the second, which is 4. And then this is 2 to the third, which is 8. And so on and so on and so forth. This is a logarithmic scale, right? I guess we should and do need to know these so I can graph these points. So this is not a Richter scale. This is much smaller. You know what? I have to keep going. What am I? Oh, look at this. I love it. This is a marvel. 2 to the 7th is multiplied by another 2. 2 to the 8th is multiplied by another 2. And now what I could do is graph these points. So here's where Scarlet Witch belongs. She's right here because her number is 3 in power. All right. 7, Black Panther, is right here because here's 8. 38, Ant-Man is somewhere right around there because here's 32. Oh, I skipped Iron Man, 18, which is just past 16. And then 265 is here. Okay, so why do we have these scales? So we can condense the scale and see things on a smaller version. Richter scale, it's powers of 10. And then that's why anything that's 10 to the 6th power, that's Richter scale 6. All right, and that's how come it's so catastrophic as we go to Richter scale 7 and 8. 8 actually represents 10 to the 8th in power. Okay, and then now base 3 and do the same thing. Well, that just makes these all 3s. 3 to the 0 is 1. 3 to the second is 9. What this does is condenses it even more because these numbers get bigger faster. 3 to the 4th is 81. And then 3 to the 5th is 243. I'll do the math for you. I don't expect you to know 3 to the 5th is 243 without a calculator. I do expect you to know 3 to the 4th, though, which is what I wrote up on the top. And now these same, oh, I skipped one. I'm a moron. Oh, no. I just ruined all your notes. Yeehaw. Who did I forget, everyone? I forgot 3 to the 1st. I got too excited. Because then I saw Scarlet Witch is 3. Black Panther is 7. And then look at these points. They condense now. 18 would be somewhere around there. You don't have to be perfect. 38 is a little past 27. And then 265 is a little out here. Somewhere past this. So look at how this condensed the graph a little bit compared to this one. All right. And that's all that this is. This is like a logarithmic scale of scaling numbers and putting them on a graph. It's no big deal. Okay? All right. We're done. Hopefully that's good. And then I guarantee Monday we're going to start off with a quiz of evaluation of logarithms. Just to make sure we're hammering it down so we can do stuff with it.